Hello everybody, today we're going to be doing some Unit 1 quadratic functions review for our quiz and the unit test, so I guess let's just get straight into it. It's going to be a bit of a long one here, so just keep on track and just try to stay with me here, and we should be good. So, to begin with, we have example 1, which is going to ask you, which of the following are quadratic functions? So, to determine a quadratic function, the highest degree of x, so highest degree of x, has to be 2. So what that means is just the highest exponent of x has to be x squared. So if we take a look at the first problem, we're just left with 3x, and we don't have an x squared there, so that's just going to be a no. And the reason why is because we don't have x squared. For this one, this is going to be a quadratic function since it has x squared. And then we have 2x cubed plus 2x squared minus 8. This one is not going to be a quadratic function since we have our highest degree of x as 3. This here, although it does not look like a quadratic, when you got one thing you have to determine, one thing you have to consider is that when you have an x multiplied by x in brackets, that's going to give you an x squared. So this is actually x squared minus 3x, which is a quadratic. So highest degree of x is 2, so yes. And then this here, you look at our degree of x's, and 2 is going to be the highest degree, so we're going to have a quadratic function. And then this here, we have plus 3x minus 3x squared. So we have 3x squared minus 3x squared. Those are actually going to cancel out. So what we're left with here is 8x plus 4. Since we have a plus 3x squared and a minus 3x squared, that is just going to give us 0. And we're just going to be left with 8x plus 4, which is a linear equation. So our linear line, so that's not going to be a quadratic. Alrighty, comparing parabolas. For quadratic form and vertex form, we must use y equals a bracket x minus p squared plus q. If a is positive, so if our a value is greater than 0, then our parabola is going to open up. And if our a value is less than 0, then our parabola is going to open down. If a is greater than 1 or less than -1, the parabola becomes more narrow. And if it's between the range of -1 and 1, it becomes more wide. So we can actually test this concept out here. Just give me a second. So following the rules that we said that if a is within this range, which basically means if it's a decimal starting with 0, oh sorry, it should be -1 like this. If it's within this range here, then we're going to have a parabola that creates a more wide shape. So effectively what this means is it just has to be a decimal starting with 0. Could be negative, 0.89 for example would work, 0.3 would work, 0.03 would work. But it cannot be equal to -1 or 1. So we can actually test this theory out here. If we just replace our a value, so let's do like 0.3 x squared, which what we said, since it's a fraction that doesn't start with 1, it's going to be more wide opposed to the whole number one. So let's check out the whole number right here. So let's say 2x squared. And you're going to notice there is a big difference in the shapes of these two parabolas. So the red one is the one we created with the a value being a whole number, and the blue one is going to be the one created with a decimal that starts with 0, or effectively within this range. So what that tells us is that basically 0.9, or a fraction starting with 0 as our a value, gives us a wide opening, and whole numbers are going to give us narrow openings. Additionally, one thing to be noted is that if a is negative, like we said, we have negative 2, for example, x squared, the parabola is going to open down and create a maximum point. However, if it is positive, it's going to open upwards and create a minimum. Moving on, now we have our p values and our q. So in vertex form, our p is going to represent the x value of the vertex. So we have a bracket x minus p squared plus q. So this is going to be x value of the vertex, and this is going to be our y value of the vertex. But what does that actually mean? So what we can do here is, if it says p is greater than 0, that means if p is positive, then the graph will move right. Since if we think about this, our Cartesian plane here, if it was y equals x squared, our vertex is going to be at 0, 0. And since we're saying our p value is effectively equal to x, if it is positive, it's going to be going to the right. Because if we're going to the left, then we would have negative x values, which is not what we're talking about here. So if p is less than 0, so p is negative, that means there were translations to the original x value to the left. So it's just going to be the opposite. So basically, if p is positive, it'll move right, and if p is negative, it'll move left, just as any x coordinate would, because it is technically x. So let's go back to this y equals x squared here, and our Cartesian plane. And now we have the same thing. So if p is greater than 0, our q is greater than 0, positive is what that means. If p is positive, that means it'll be responsible for translating upwards, because if it was negative, it would go down, right? So we're going to say the graph moves up, and if it's negative, it'll move down. And those are just a couple of characteristics to be noted about vertex form and what you can actually learn from vertex form. Example 1. The graph of y equals x squared is transformed to have the following characteristics. Vertically stretched by a factor of 1 over 3, translated horizontally 2 units to the right, and translated vertically 5 units down. Write an equation of the transformed graph and sketch it. So, as we know, y equals x squared gives us an equation, or gives us a vertex of 0, 0. First thing to consider here is whenever we're talking about vertically being stretched, that is an indicator that it represents our a value. Because a value is responsible for the shape of the graph, so that means in our equation y equals a x minus p squared plus q, our a is going to be 1 over 3. So we can just plug that in. But that isn't the only information we're given here. It says it's translated 2 units to the right. So if we have our point here, where y equals x squared is our original equation, if it's translated 2 units to the right, then we would have our point at 2, 0. So our vertex is going to be x minus 2. And we're just going to plug in a 2 here. And if it's translated 5 units down, we're just going to go 1, 2, 3, 4, 5. This is all approximate, of course. And our q value is going to be negative 5. So now this equation should represent all the translations of y equals x squared that the question is describing. So all we need to do now is actually sketch this equation. And the way you do that is first you have to find the vertex. In our case, we already know what it is since our vertex is going to be 2 comma negative 5 here. So I would just say that it's like about like right here. I'm not going to be approximate, but negative 5 and then 2. And then you can actually plop this in your calculator. But just remember when you're working with fractions, you always want to include a bracket beforehand. Like what I mean by that is like 1 over 3. Like that. You put the fraction in the bracket. And then you can type out your equation. So you'd x minus 2 minus 5. Or x minus 2 squared minus 5. And then that should give you the equation that was described. So we have our vertex at 2 comma negative 5 here. But what we're going to do is we're actually going to find the two x-intercepts to graph this properly. So what you do is you set your y1 to your equation, and then you put your y2 as 0, because where x is 0, where the graph crosses the line, you want to find the intersection point. So you just put your y2 as 0, and then you go second trace, intersect, and then you hover over the point on the graph where the intersection is, and you get negative 1.87 equals x, and you want to find the other one too so we can graph this, so I will just do that. And you should get here 5.87. Okay, so now we can just graph these 2 points. So let's say 5.87 is over here, negative 2 is over here. You just connect these points like this, and you add the 2 arrows, and that is your nice little graph there. It's not going to be too great. Obviously, if you're prompted to actually graph this and make it nice, obviously label your axes here, x, y, put a nice scale on your x and y, and just label every point that you're plotting down so you don't lose any additional marks. So now we're actually going to expand our knowledge of vertex form and determine an equation or a function in vertex form based off of a graph. So the way we do this is by finding a couple key points. So the first point we're going to find is our vertex. Since our vertex is going to give us our p and our q value of our vertex form. So we have y equals ax minus p squared plus q. And we'll just have two variables knocked out straight away. So the way we do this is we're going to analyze our graph here. So we have negative 2, comma 2 as our vertex. So our vertex is equal to negative 2, comma 2. And now what we can do is you can look for any point on the graph, preferably a nice point. Yeah, so just find a nice point here. So there's a couple nice points on this one that we can see. There's negative 3, comma 0, it looks like. It doesn't matter what point you pick, again, you can just plug in any point since this is going to be the same exact equation here. So we also have negative 1, comma 0. Additionally, you could also pick this one down here, which is negative, or 0 and negative 6. So whatever one you choose is okay. I'm just going to pick negative 3, comma 0, so it's nice and easy. So the way we do this is I'm just going to define what we have here. So we have negative 3, comma 0 as our selected point, and we have our vertex as negative 2, comma 2. So our point here is going to represent x and y within this equation here. So just label it x, y, and our vertex is going to represent p and q respectively. So once you place these variables in, you're going to notice that you're only left with a, and you have to solve for a and then plug it back into the equation. So I will show you what that's going to begin to look like. So let's just plug in everything that we got. So y equals a, which we don't have, x, which we got as negative 3, minus p minus -2 squared plus q, which is going to be 2. So we get 0 equals a, and we have within this bracket -3 minus -2. So when you're subtracting by a negative, that just means you're going to add. So we have 3 plus 2. -3 plus 2 is going to give us -1 squared plus 2. And once we have this, what we can do is we can just evaluate what's in the bracket. So we have a times, or a to the 1 plus 2. And you just subtract 2 from both sides to isolate for a. And you get a is equal to -2. However, at this point, we're not completely done. So what we need to do is actually go back and create the equation. So we got what a was equal to. So all we need to do is just fill it in. So we have y equals a, which is what we got as -2. And then x minus -2. And remember that the rule applies when you're subtracting by negative. You're just going to be adding. So we can simplify that to a plus 2 squared plus what we got for our key value, which is 2. And this should be your final equation. And we can actually test this out by plotting it into our calculator and seeing if we have points that match up. So I'm going to plug it into my calculator and I will show you guys what it looks like. Alrighty, the equation you should have plugged in should begin to look like this. Remember? And we're going to see how the points start to match up. So if we compare to our sketch here, we can see that we have an intersection at -3, 0, one at -1, 0, and our vertex looks to be about -2 and 2. And we can actually test our y-intercept to see if it matches. So we set x equals 0, and it gives us -6, which actually matches up to this point here. So that's how we know this line is correct. You graph it, you take a look. If the vertex is the same, the two intercepts look about the same. They should be the same. But if you pick a nice point, they will be 100% correct. So, and what I mean, yeah, that should be fun. So this is your final equation. Alrighty, on to the word problems. So now we have example 4. Parabolic archway has a width of 3. So what this actually means is this whole thing across is going to be 3 feet. And a height of 9 feet at this highest point above the ground. So our highest point, that we know is our vertex, which represents our max here. So I'm going to use a better color, sorry. I'll use like blue right now. Okay. So we have, if we think about this, we have a point at 3, 0. And then we have our height here at 0 or x, 9. We're not sure what it is yet. However, we can just graph this out here, or we can kind of visualize. So what I mean by that is we just draw a kind of positive quadrant. And it's going to be quadrant 1, because these lengths have to be positive here. And we have 3, and then 9 up here. So what that automatically means is that the x value of our vertex should be half of what 3 is. Since we have it between 0 and 3, we can just divide 3 by 2. And we get 1.5, 9 as our vertex. So now what we can do is we can begin to actually create an equation. So the way we did that is going to be similar to the last one. We're given the point 3, 0. So I'm going to write that down. And this is going to be P, this is going to be Q, this is going to be X, and this is going to be Y. And effectively what we're doing here is we're going to solve for A again. So we have Y equals AX minus P squared plus Q. And all you have to do is just replace your givens. So we have 0 equals a x, which we had got as 3, minus our p-value, which is 1.5, squared plus 9. And all I'm doing is just plugging it in there. So we get 0 is equal to a 3 minus 1.5 gives us 1.5 squared plus 9. And 1.5 squared is going to be 2.25. So we get a 0 equals a 2.25 plus 9. Subtract 9 from both sides. You get negative 9 equals a 2.25. And now you just divide by 2.25 on both sides. So you get negative 9 divided by 2.25 should give you negative 4. A equals negative 4. One thing to note though is when you have this bracket here, a times something, you're actually multiplying these two values together. So that's why we have a 2.25. And yeah. So make sure you're not making that mistake of leaving this bracket on its own. What I mean by that is just multiplying a by whatever you get in this bracket, and you should get the right answer. So we got a is equal to 4. So now we can set up an equation. So we got y equals negative 4, which we got for a, and then our x, which we're just going to leave, our p, which is going to be minus 1.5, squared plus 9. And I'm actually going to graph this out to have a visual representation of this. So once you plug in your line, it should look exactly like this. You're just going to hit graph. It should be in your quadrant 1 that you're focusing on here. So you're going to notice that our intersection, this point here, is going to be 3, 0. We start at 0, 0. And just to make sure, you can actually check your vertex by going maximum and seeing if it lines up, which it should. Left and right. And you're going to get 1.9, 9. Or 1.5, 9, which actually matches up to your vertex here. So that's how you know your equation is going to be correct. Alright, your turn. Parabolic mirrors are often used in lights because they give off a focused beam. Consider the parabolic mirror pictured below. Write a quadratic function in vertex form that models a parabolic mirror. So the way we do this is we're just going to create this little graph here. And you're going to notice, opposed to the last equation where we had a maximum point, this parabola actually opens down, or opens up actually. So we're going to have a minimum opposed to having a maximum here. So that's just one thing to note. And since we're given our point here, we have this is going to be 1, this point is going to be 6, and then our vertex is going to be half of 6, since this is 0, 0, and we get 3, 0 as our vertex. And then we have 6 here, and since we have it at a height of 1, this point right here, as described, is going to be 6, 1. It's just a little bit of visualization, but once you learn how to actually like picture this in your head and make a graph out of it, like sort of like I did, it'll be light work. So that's going to be our point. We're going to label x and y, p, q respectively. And now you're just going to plug and replace. So you're going to use the equation a equals ax, or y equals ax plus a bracket x minus p squared plus q. And now you just plug in your values. Alright, once you plug that in, you can now begin to solve. For a, we get 9. 6 minus 3 is 3. Negative 3, or 3 squared is gives us 9, plus 0. Plus 0, we don't have to do anything with that. So we're just going to get 1 equals a times 9. And you're just going to divide by 9 on both sides to cancel out and solve for a. So you get a is equal to 1 over 9. And now what you should get as your final equation is when you plug it back in, you have y equals a, which we got as 1 over 9, x, and then you're going to have your parabola here. So we have x minus 3 plus 0, x minus 3 squared plus 0. And since we're adding 0 onto the end, we don't actually have to write that. So our final equation here is going to be y equals 1 over 9, x minus 3 squared. Again, you can plug that in your calculator and test if it creates a sort of similar graph with similar points. But due to time constraints, I'm not going to do that right now. So, but that is correct, so yeah. Completing the square. Your turn. Rewrite the following function in vertex form by completing the square, then state the coordinates of the vertex. So the first step in completing a square is actually breaking or kind of grouping up your factors here. Is what I mean by that is actually you're just gonna group these two boys up. 3x squared minus 6x, and you group these things up. And in order for completing the square to actually work, your x squared value is going to have to be, or x squared coefficient is going to have to be 1. Because otherwise it doesn't work. So all we're going to do here is just factor out a 3 since it's in front of the x. So you get x squared minus 2x plus 14. Now what you can do is you can label these a and b. And what you do to complete the square is you're just going to take your b value, so you have negative 2 as b. You're going to divide it by 2, gives us negative 1, and you square it. Now you get 1. So inside the bracket, what we're going to do is we're going to create a perfect square, or perfect square trinomial here. So we have plus 1, which we got as our c value. But since we can't just add random numbers to this line here, because then it would just completely shift it, we have to cancel out the 1 that we just added by subtracting a 1. And this is like just a rule that you guys are going to have to follow. So we can't actually factor this right now because we have 1 plus 1 minus 1. So what we're going to want to do is we're going to want to take out the other c value you just added. So not the positive one, but the negative one. And you're going to take it out of your bracket. And the way you actually do that is by multiplying by what's in front of your bracket. So what we factored out at the beginning was a 3. So to take this out, you just multiply it by 3. So you have 3x squared minus 2x plus 1 minus 3, since we just multiplied it out of the bracket, plus 14. And now what I like to do is collect the like terms on the end. So get 3x squared minus 2x plus 1 plus 11. And all you need to do now is just factor this down here. However, there's one thing I want you to keep in mind. You could technically factor this by doing a times c, or two numbers that multiply to 1 and add to negative 2. But you're going to notice that when we divided, to begin with, when we tried to find our perfect square trinomial, we did this process right here. So when you divide your b value by 2, whatever number it outputs, we got negative 1 in this case, will be the number of your factor. And what I mean by that, we got negative 1. So all it's going to be is x minus 1 squared. So you're just taking that, whatever you got, and you're putting x in front of it, basically. So if it was 1, it would be x plus 1. But in this case, since it's x minus, or we got negative 1 as our b value after we divided it by 2, we're going to get x minus 1 plus 11, which is our final answer here. And the way you actually check if you converted it properly is by graphing the original equation as your y1, and your second equation that you altered and simplified down or converted into another form is y2. So I'm going to show you what that looks like. Alright, so once you plug it in your calculator, it should look like this. So this is the equation, y2 is the equation you created, and y1 is the original equation that you're given. So when you graph these things, what it should create is two lines that overlap each other and create the same line, effectively, is what it is. So I'm just gonna speed this up real quick. And I don't think these lines are within our window, so you're just gonna adjust that, zoom out, and as you can see, the two lines overlapped. And if you don't have a TI-84 CE, what you can do is you can actually go second table and then look at your y1 and your y2 values. As you can see, the y1 and y2 values actually match up. And this is due to the fact that they're the exact same line. So at where x equals 1, y1 equals 11, and y2 equals 11. Where x equals 0, y1 equals 14, and y2 equals 14. So we know that this is the exact same line, and we completed it correctly. So here we have an equation, or a problem, that actually kind of challenges this concept, challenges your understanding of what's going on. So I'm going to write this out so it's not as confusing. But instead of C, you're going to notice we have a placeholder that is going to be M. So the way we actually solve and complete the square here is we're just going to do the exact same thing and pretend as if M was an actual number. So again, we're just going to group up the first two. We're going to group up A and B. And we're going to factor out whatever's in front of x. So in this case, we have 3 in front of x. So we factor out a 3. And 3 divided by 3 is 1. And 6 divided by 3 is going to give us 2x plus m at the end. So now we're just going to do the same steps. We're going to label this A and B. And remember that your B or your C is going to equal b divided by 2 squared. So we're just going to divide our b value by 2. So we have 2 over 2 equals positive 1 squared equals 1. So this is the c value that we're going to plug back in. So we have 3x squared plus 2x. Again, we're going to add this 1 at the end to complete the perfect square trinomial. But since we can't add just random numbers into equation, we actually have to cancel it out by subtracting a 1. So we have plus x squared plus 2x plus 1 minus 1 plus m at the end. And now what you can do is you can bring this negative 1 out, like the rules should apply. And you do that by multiplying it by the coefficient. So we get 3x squared plus 2x plus 1 plus 1, or plus negative 1 times 3 is negative 3 plus m. And now what we can do is we can actually factor this down. And if you remember the trick here, all we have to do is take the b value which we divided by 2. So our original b value was 6, or our original b value is 2, which we divided by 2, and we got positive 1. And in our bracket, all we do is add an x in front of that. So we get x plus 1, and then square it, minus 3 plus m. And that should be your final answer. And now you're probably wondering, how exactly do I check this, right? Because at the end, you don't really have a number that you can plug it in your calculator with. So the way that you check this is you set a random number. So, okay, let's say m is equal to 3, okay? So in place of m, we're going to put 3. So this is the equation we created that we said was equal to. And then we're going to use our original equation, which was 3x squared plus 6x plus m. Okay? So now that we've set m equal to 3, all we need to do is just graph the two equations with m being 3. And if it was simplified properly and converted properly, the lines should overlap over each other. and the table should look the same. So I'm going to plug in the one that we created, x plus 1 squared minus 3 and plus m, okay? So plus m, which was, we set to 3. And then on the other one, we have 6x squared plus 6x plus our c value, which is m, which we set to 3. So now these guys should overlap. And what do you know? They create the exact same line. So we'll just go in the table and just check it, y at 1, and these should be the exact same values, which they are. So now you know that you simplified both of these properly. So this is your this is your correct equation. So that one was a bit of a tricky one. It's a lot of steps there, but all you need to do is just, you can test very easily by just setting m equal to whatever you would like. And honestly, like, it doesn't matter. Just make sure when you're setting m to equal to something, you're putting in brackets. Because if you put like a negative like 10 or something, make sure you're putting bracket negative 10. And what I mean by that is, say at the end of this, I set it to negative 10, right? And in the bottom, make sure it's negative 10. So that it actually ensures that it stays the same. Yeah, so the line should be the same. So yeah, we did it correctly, and good job. Nice. Let's move on. Okay, consider the following quadratic function, 3x plus 2 squared minus 5 in vertex form. So here we're converting standard or vertex form into standard, whereas completing a square, we converted standard into vertex. So we're just doing the opposite here. So we have y equals 3x plus 2 squared minus 5. So the way we convert vertex and the standard is we're actually just going to FOIL these two, this x plus 2 squared out first. But make sure you maintain it in brackets. And what I mean by that, since we have a 3 out front, you have x plus 2, or sorry, it should look like this. I'm going to use alternative brackets. Times x plus 2. We're just writing it out, minus 5. And then now we can actually just FOIL it out. So x times x gives us x squared. X times 2 gives us plus 2x. X times 2x gives us 2x. Or x times 2 gives us 2x. And then 2 times 2 gives us plus 4. So once you factor it out, or once you FOIL, it should give you x squared plus 4x plus 4. And we have that minus 5 at the end of it. And now, since we kept it all in brackets, we actually have to distribute this 3 onto everything before we can subtract 5 at the end here. So just make sure you're multiplying 3 by everything. So we have 3x squared plus 12x plus 12 minus 5. And now you can actually just subtract and collect like terms at the end. So you get 3x squared plus 12x plus 7 as your final function. And again, as usual, always double check. And the way you do that is just by plotting these two lines and making sure they overlap. And if you don't have that function, make sure you're going in your graph and actually manually checking if the values are the exact same. But this is going to be correct, so we don't have to worry about that. So now that we've actually converted the line into standard form, we have to algebraically determine the vertex. So the way we do that is we use p equals negative b over 2a. So our p value, or our x value of our vertex, is equal to our negative b over 2a. So what that means, we have a, b, c, once we label this, and we're just going to plug in b, for example, which is 12, and then 2 times 3. So you just get negative 12 over 6 gives you negative 2 as your x value or p value of your vertex. So we have negative 2 And since you got that as your vertex, the very highest point or highest or lowest point, all you need to do is you have to plug this -2 back in to get the y value of your vertex. So since we found the x value, remember how equations work, right? So this is y, and we're just going to plug in where x is the vertex. So it's -2 squared plus 12 times -2 plus 7. And I'm going to put that all in my calculator. And once you do, that should give you the y value of your vertex. All right, I got -5 as our answer here. So it should be -2 comma -5. And we determined that algebraically. So yeah, that's how you do that. Moving on, we have our example 4 here, which says a bomb traces the arc of a quadratic function. The meters of the bomb in function of the time as a function of the time. Or okay, so the way we do this is we have to actually understand what this is going to look like. So we're going to notice that this graph starts not at 0 0 where traditionally it would, but rather at the y-intercept. So what that could represent is it could represent a person probably maybe standing and throwing it from the top of their head, or it could just represent like the starting height, which we'll just say. So starting height is equal to our y-intercept. So to find your actual y-intercept, what you can do is you can find it in your calculator. So what you do is you're just going to graph this function here. Since we're given an equation, let's just graph this. So -16x squared plus 32x plus 1.5. And I'm just going to reset my Zoom schedule, or my Zoom. And we're just going to go second trace value. And this is where you can put any value for x. And since we know that when we're trying to find a y-intercept, we have to set x equal to 0, which we're going to do. We're just going to put in 0. And we're going to get y equals 1.5. So our y-intercept is 0, 1.5. So next question is asking, what max height does the bomb reach? And when does it reach that height? So the max height refers to our vertex. So our y value specifically of our vertex. And when it reaches that refers to our x value of our vertex. So it's just asking, since time is our x and height is our y, what height does it reach and when does it reach that height? So we do that is just we're just going to do second trace maximum, and we're just going to find the vertex. And you have 1, 17.5. So what this tells us is that since y is equal to our height, it reaches 17.5 meters at 1 second of the path thrown. Alright, nice. So now we have how high is the bomb after 0.25 seconds. So we know seconds in this case is equal to x. So what we can do is we can replace our x with 0.25. So remember that second trace value actually finds a value of x on your graph. So you just put 0.25 and you get x at 0.25 is equal to 8.5 meters. So we're just plugging in this 0.25 as a value in our calculator. And that's effectively how you're going to do this. It's pretty easy. And yeah, we just have 2 more word problems and then we'll be done. Alrighty, so now we're going to be doing our first word problem that you're going to be encountering in Math 20. And the way you actually do this is it's going to be a very certain kind of formula that you're going to follow. So let's just read the question first. So we have a movie theater charges $4 per ticket. So I'm going to underline that. It has a typical audience of 400 people. The manager estimates that the audience will decrease by 10 for every $1 increase in ticket price. What is the ticket price that will generate the maximum revenue? All right, so first I want to define our variables, and this is going to be pretty universal across Math 20. So if we're looking for maximum revenue, revenue is always considered to be y. So we're just going to do y is equal to revenue. And in this case, our x is going to equal our increase in price. So now we can actually create an equation, but we're going to open one bracket and open another, open one and open another, and set it equal to y. We're creating an equation in factored form for these ticket questions because that's the formula that it kind of follows. And what we do is we're going to set one of these brackets. So one of these brackets is going to be in relation to ticket price, so ticket cost, and the other one is going to be in relation to population. And you're going to see what that is going to mean in just a sec. So ticket price. We have our initial ticket price, which is 4. So I'm going to put down a $4. So always put the initial amount first. And you have an initial audience, like to begin with, of 400 people. So put 400 in the second, since we have 400 people and that's population. And now this is where it gets kind of tricky. You have to look at this and kind of analyze what's going on here. So the manager estimates that the audience will decrease. To decrease means to subtract. So we're subtracting 10 from our population for every increase. And you're going to notice that we set our increase equal to x. So we're going to put x times 10. And our first bracket is going to be 400 minus 10x. In our second bracket, it says it will decrease by 10 for every $1 increase in price. So we have to do plus 1 since the increase is going to be $1. And we're going to have 1 times x. So that's going to represent how many times the price is increasing by. And yeah, so this bracket is your ticket price. This one's your population. Multiplied together, they should give you your revenue. So I just want you to remember these two things. So what we can do now is we can pop this in our calculator and actually graph it. So we have bracket 4 plus x, bracket 400 minus 10x. And my window settings are a little weird right now. So initially you're going to get this, sorry, wait, I need to fix my camera here. Yeah, so initially you're going to get this weird line and you'd be unsure what to do with this. So what I do is you just go zoom 3, and then you go top corner and you press enter and you just kind of adjust your window setting until you can see both of the lines. And then now you can find the vertex by going second trace max, and you're going left and right of the parabola here. And you're going to get 18, 4840. And what this actually represents is that at an $18 increase, which we set to x, we're going to get a max revenue of $4,840. So our vertex represents the highest point on our graph. And we know that our highest point of y is revenue. So this is rev, max rev. And this is the max increase, or the optimal increase in this case. So it's asking us for the ticket price now. So our vertex doesn't really tell us much about the ticket price. It tells us how much we have to increase our price in order to maximize our revenue, right? So we're going to notice that we set one of our brackets earlier equal to the ticket price. And that bracket was 4 plus 1x. Okay? And that is equal to ticket price. And since we found the optimal value of x for our revenue to be maxed, all we have to do is plug in the optimal increase, the x value of the vertex, in other words, into our ticket price bracket. So what that means is you do 4 plus 1 times 18 in this case. And you're going to get $22 as your final answer, or $22 per ticket will be the optimal amount, or will be the optimal price to maximize revenue. And I know this question isn't asking for the max revenue, but this would be your max revenue. So the Y value of your vertex would be the maximum revenue. So at $22 per ticket, you will have a max revenue of $48.40. Hope that helped. We'll move on to the next one now. Alrighty, final word problem that I'm going to go over with today. So we have a rectangular lot is to be enclosed by a fence and split into 3 equal sections by 2 fences parallel to one of its sides. So I'm going to draw just a visual representation of what this might look like. So we have a rectangular lot is to be enclosed by a fence. So this would represent the fence here. And split into 3 equal sections by 2 fences. So this would be fence 1, this would be fence 2, and these 2 fences are all, fences are all parallel here and parallel here, which meets the question criteria. So determine the maximum dimensions that result in a maximum area. So we have a fencing available. The fencing available is 600. So what that actually means is that the person that's actually building this fence only has 600 meters of fencing to go over here, and just create the shape, right? So when they say fencing available, that is going to be in reference to the perimeter. So we have to create an equation for perimeter here, but this one is going to be more tricky because perimeter, if you remember, is all sides added up together. However, in a normal triangle or a normal rectangle, this would be like length, and this would be length, and this would be width, and this would be width. And you could just add these 2 and add these 2 here, and that would give you perimeter. But since we have 2 more additional sides, we actually have to account for the fact. So the way we actually write this equation now is going to be, I'm going to write length and width. So since we have width, I'm just going to label that as width, and then length, and you just have to label these 2 sides here. So your picture should start to look like this. And what this means is 4 lengths plus 2 widths is going to give you 600. And since we're looking for dimensions that maximize the area, we have length times width equals maximum. So now you've created 2 equations. The thing you're going to need to do is you're going to have to look at it, right? So we have length times width equals max. And in this equation, we have no numbers. So the way we actually solve this is we have to get numbers somehow, right? And the way we do that is by isolating for one of your variables, either length or width in this case, in your first equation that has numbers, okay? So just to make it easy, I'm going to solve for W here. So the way I do that is you're just going to subtract 4 length from both sides. It should cancel out. You get 2 width is equal to 600 minus 4 length. Divide everything by 2 and you get 300 minus 2L as your isolated variable. So now that we have what W is equal to, we have to plug it back into our other equation that has no numbers within it. So in bracket, since you're plugging it in, you have 300 minus 2L times L is equal to max. And honestly, at this point, you could graph it in, or you could just put this in your calculator and it would generate the same line. However, I'm just going to do the distribute property here. So we're just going to multiply L by this and L by this. And that should give you 300 L minus 2L squared gives you a max. So the max is going to be our y of our, so PQ. Our maximum area is going to represent Q in this case. And the length in which is optimized is going to be L here. So I'll show you what that means soon. So what we have to do is we actually have to plug this equation into our graphing calculator and find the vertex. So your equation should look like this in your calculator, 300x minus 2x squared. And once you graph that, you're going to see there's nothing normally. So what I'm going to do is I'm just going to press zoom 0. And what that does, it just gives you what you think, what the graphing calculator thinks you need. However, since this is not the best view, you can just begin to adjust it by going zoom out and then, just kind of fiddling with it until you get something that you like here. All right, so I like this. So now we can just find the vertex here by finding our max. And we got our x is equal to 75. So we got 75, comma, 1250 or 11,250. So this is going to be L and this is going to be our maximum. So we found our maximum area. So this is our maximum area. So we have 12,250 and meters squared equals max area, since that's our vertex. And now we actually have to figure out what to do with our length being equal to 75. So you're going to remember in our original equation, we need to find the lengths that optimize the area, but also fall under the criteria such that you don't overuse the 600 meters of fencing, right? So our original equation for perimeter was 4 times length plus 2 times width is equal to 600. And now that we have what length is equal to in our parabola and our vertex, all we have to do is just plug in the value of our vertex here, which is 75 plus 2w. And then we're going to solve for w to find the other dimension that creates a maximum area, but also falls under the criteria of the perimeter. So when we do this is we just do 4 times 75, and you get 300 plus 2w equals 600. Subtract 300 from both sides, you get 2w equals 300, and you're going to w equals 150. So now you got your two lengths as 75 and your width as 150, and you got your maximum area as 1250. So the way you actually test this is that you have to make sure it falls under the criteria, right? So if we put 75 back into our original equation, plus 4 plus 2w. So our original equation for perimeter is this. If we're just going to plug in our width and length, it should give us 600 back, which is 150. Spoiler alert, it will give you 600. So that's how you know that this checks out to begin with. And all you have to do now is check that the area actually makes sense. So when you multiply your length and your width, it should give you the area of 12 or whatever you got as your y value of your vertex. So you get 75 times 150. And what do you know? You get 11250, which matches the y value of your vertex. So now that you know your length is equal to 150 and your width is equal to 75. And that's going to be the two dimensions that result in the maximum area. So that was a lot of work there. I know it's a little tricky to grasp, but honestly, guys, the more you practice it, the more you do this, it'll start to make more sense. So just keep practicing. It should be pretty easy once you get the hang of it, and don't stress about it because, yeah, that's the worst thing you can possibly do. I'm just going to go over one last thing, and then we're going to wrap this up. So if we go back to, if we recall what I said earlier about our A values, right? So if the A falls within this range here, that means that we're going to have a wide shape. And if it's outside of the range, which would be this, or shape, and then A is less than -1, or A is greater than 1, which is outside of the range, it's going to have a narrow shape. But this is also an indicator of how high the value of the A value is actually. So for example, for instance, if I were to give you 4 different graphs and ask you to arrange them just by looking at them, like for example, we have this graph here, this graph here, this graph here, and this graph here. And I ask you to arrange them in which the A values have the lowest to highest value. You can do it by just looking off of it. So you know that if it's a fraction with 0, it's going to have a wider opening. So if it has a wider opening, that means it's a decimal that starts with 0. So a point x, and since it opens down, we can actually apply a lot of the concepts onto this. So here we have our parabola, and since this is opening down, that means our A value is negative, right? And since it's wide, that means it's a negative decimal that starts with 0. We have our second one, which is narrow, which we know is going to be a whole number, either negative or positive, but we know it's negative because our parabola, again, opens down. So we're just going to have negative A. And then we have this one, it opens up, so our A value is positive, and since our graph is more narrow, we're going to have a whole number here. So we can just put like 1 as A. And then we have this one. It's opening up, so our A value is positive. And since we have a wide shape, our A value is going to be a positive decimal. So if you were to arrange these from lowest to highest, it would go as follows. You would have this graph first, this graph second, this graph third, and this graph fourth. Since this is a negative decimal, this is just a decimal, and this is the whole number. So those are just some concepts of applying the A value. And I'm going to do one more question, and then I promise we'll wrap this up. It's a theory question, so it should be quick. All right, this is taken from Alberta's exam. So we have, consider the following function. F of x is equal to 3x minus p squared plus q. So the only thing we're given here is the A value. So we're going to be applying some of our concepts here. So we have to find which statement is not true for f of x. So there's going to be 3 that are true and 1 that is wrong. So A, when q is equal to 0, the graph of f of x has 1 x-intercept. So what we're saying is that if our vertex is at 0, right here, since our q is in relation to our y, our vertex is going to be literally at this point right here, at 0. So if it's at that point right there, you're going to notice that it does create 1 x-intercept, since it only touches the point once. So this is going to be true. The graph f of x has the same size and shape as the graph of 3x squared. And remember that when we're talking about size and shape of a graph, that's going to be talking about our A value. And since our A value is 3, and the A value is 3 right here, that means they're going to share the same size. So the graph shares a minimum value at y equals q. So in order for y to have a minimum, our A value has to be positive, and meaning it opens down. It opens up if our A value is positive, in which 3 is a positive number, meaning it's going to open up, meaning we're going to have a minimum value at q, so this is going to be correct. By process of elimination, D is going to be the incorrect answer. And the reason being, also, is because axis of symmetry, x is equal to p. The only case in which x is equal to negative p is if it was 3x plus p squared plus q. Because this would just be the inverse of it, which is negative p. But in this case, it's not, so that d is wrong. It's so wrong. Okay, anyways. The domain and range of f of x, respectively, are... So we know that when we have a parabola, our domain is immediately going to be x as an element of the real, so we can cross out these two answers to begin with. And since we have a minimum is the lowest point. So that's the lowest y can get. So y has to be greater than that lowest point. So this is saying that y is less than q, which would be true if we had a maximum, but since we have a minimum, this is going to be completely incorrect, meaning our only answer here is going to be C. Alrighty guys, that is going to be it for the unit test exam. I wish everyone who watched all of this good luck. And as always, if you have any questions, always leave them in the comments. Feel free to message me, whatever. I hoped everything helped. I hope this video helped a little bit in the slightest. And I just wish everybody good luck. Yeah, you guys got that.